Yeah, thank you. Afternoon, everybody. As mentioned, my name's Tate Baillie. I'm a principal mining consultant with AMC Consultants based in our Melbourne office. We've been using Minemax Scheduler for a number of years for strategy planning across a number of different mining methods and commodities. And today I thought I'd delve into our extensive back catalogue and go through a case study looking at the application of Minemax Scheduler in a heavily constrained environment. So I think we've sort of talked about, how much value Minemax Scheduler can add when you have a, relatively unconstrained schedule with just a few constraints. This project in particular that I'll be talking to had quite a few, and I sort of just want to go through how we managed to add value even with significant numbers of constraints. So just a bit of a rundown. I'll give an introduction into AMC. It'll be very brief, I promise, and also why we use Minemax, and then go into a bit more detail into the case study. So AMC Consultants, we're a global consultancy working across numerous jurisdictions. We've got a 30-year history with Datamine, so we're pretty familiar with their product suite, including Minemax and obviously Studio. We cover all aspects of mine planning, from mining engineering, geology, geotechnical, etc. And we also have an advisory team who focus on strategy optimisation using some of AMC's proprietary tools like the Hill of Value, and also leaning on our extensive benchmarking database, which has been compiled from a number of years and different projects. So I think Datamine and Minemax's flexibility really suits project work where we're constantly faced with new and unusual challenges. So that's sort of the main reason why we have gone down that path. So I guess why Minemax? The traditional approach to strategic mine planning is often a bit more linear and an iterative process, whereas Minemax is a fully integrated solution that allows us to run many scenarios very quickly, and also incorporate what would have previously been outputs along the way to feed into the schedule at the start, which allows us to really identify the optimal strategy up front. When do we use it? Well, the majority of our consulting is at the early project life. At these early stages is when we're really wanting to define the key parameters for a project. Often people can make the mistake of trying to do things right rather than doing the right things. So I think it's, sorry about that little buzz phrase, but I think that's really the benefit of Minemax, because we can run these scenarios very quickly, and it's a great tool for these early stage project planning. We do also use it in the operational stage. We've been brought in to redirect strategy in a number of underperforming assets in the past, and I think it creates practical solutions really through the application of all the different constraints that you can use, such as plant size constraints, fleet sizes, mill blends, advanced waste dump modelling, and the like. So we've also tested these the strategic schedules we've done. We've tested them in a resource-based scheduler to see if they're actually realistic and achievable, and so far we haven't come across one that we haven't been able to replicate, which is a good sign. So on the case study, I know most here are probably from a coal or similar background. However, the majority of our project work so far has been in either hard rock metalliferous or mineral sands operations. So those familiar with the mineral sands mining process may see some similarities and potential applications of the findings of this study to, say, a coal strip mining operation. So I'll be presenting a case study around a mineral sands operation that we did some work for. I've tried to sort of beige it out a bit because some of the information was sensitive as they are a client of ours. So I think it's probably actually good that the previous three talks were looking more around the setups and how you actually use Minemax. This is probably going to be more focused on the outcomes that we found when we did the Minemax scheduling. So the goal, we were engaged obviously to develop a practical mine sequence that maximised the project value. However, there are a number of constraints to consider, such as relocation of gazetted roads, looking at the effect of variable mining and processing rates, as well as a number of significant ESG considerations around land access and noise constraints and rehabilitation to final landform. And also we incorporated a backfill schedule into this because that was obviously a key part of the project. So the mining concept, pretty straightforward. The topsoil is cleared, removed and stockpiled. The overburden waste is mined using conventional truck shovel with excavators and trucks, and then a front-end loader coupled with a dozer feeds the ore to the mining unit plant. where it's mixed with water to create a slurry, which is then pumped to the wet concentrator plant. The fine tails created from the wet concentrator plant are disposed in a tailing storage facility, and then the coarse sand tails are combined with the overburden waste and backfilled into the voids. So I've just got a little image. Oh, hang on. Is this? Oh, sorry, that's the next one. Sorry. So on consultation with the client, the design parameters are agreed upon to maximise the productivity based on the ore body geometry. So just from this little schematic here, you can sort of see the process here. We have an excavator, or mining's progressing from strip 1 down to strip 6. Actually, that cursor's not actually working. But, so strip 1 down to strip 6. We've got an excavator here mining, loading into trucks, which is short hauling to the nearest available dump void. Behind that is the front end loader mining the ore and feeding it to the MUP where it's pumped to the wet concentrator plant. Oops, there we go. So the first step was the pit optimisation. So we did a conventional Lurch-Grossman optimisation, which created some nested pit shells, which were corresponding to a decreasing value per total tonne. This was then coded into our resource model and imported into Minemax Scheduler, and we ran a scheduler with the sequence defined by the optimised pit shells. So this is a relatively unconstrained schedule at first, and as you can imagine, the shells didn't define a natural strip mine, but it was really used to give us an indicative theoretical limit for the project value that we can then use for a comparative analysis going forward. We then overlaid heat maps corresponding to value per total tonne and value per ore tonne, and a practical strip mining geometry was applied to generate an indicative sequence for each scenario. The reason for this was we really wanted to test the sensitivity on strip ratio. So if we look at the top one here, this is the value per total tonne, which is indicating we really want to sort of take this material and then move down through here. Whereas this one, it actually quite like this area here, and I'll go into the reasons for that later on. So the reason why we assess these and why it relates to the strip ratio is because our primary constraint was around the wet concentrator plant throughput. So that was our real target rather than the material movement rate. So on assessing them, if there was massive fluctuations in one and a sort of smoother profile in the other, then maybe, you know, we would choose one or the other. And so what we found was that the value per ore tonne scenario compared most favourably to the LG shell scenario. It was only a slight decrease, 0.9% discounted cash flow versus 3.5%. There was a variable strip ratio in both scenarios, so there was no real benefit in either from the material movement perspective. And so we went forth developing our base case based around maximising the value per ore tonne. So this was our base case sequence. As you can see here, we've now separated our mining phases by some of the roads. So you can see sort of coming down through here. The general sequence was targeting the value per highest value per ore tonne material earlier, as I mentioned, and the starting point was determined based on the initial backfill location, which was in this valley here. So you can see number 1 here progressing to the north, coming down through here, and then taking this material and so on and so forth. At this point, this scenario had no consideration around the road relocation costs, as it was sort of our base case scenario that was relatively unconstrained. We then started applying some of these constraints. So we had some road diversion costs, which we estimated, and we put forth a number of scenarios that had different diversion schedules. So whether we divert the roads early, you know, later on or whatnot. So we set these costs up in Minemax as a capital expenditure item to release the blocks adjacent to the roads for mining. And what we found was that the highest value schedule saw the majority of the diversion costs incurred in the first 3 years. And so deferring these costs would have had a detrimental effect on the phase sequencing and thus the project value. When we looked at the costs in comparison to the value, they were orders of magnitude smaller. So they probably didn't have a large impact on the overall project value. One other thing about the road relocation is that it necessitated a realignment of the phases to the west of this road here. So previously these strips were aligned east-west. We then changed that to north-south. The reason why was to expedite the backfill and subsequently return the roads back to their original alignments as soon as possible based on the community requirements. This actually helped smooth the material movement profile as there was a bit of a hill here with a much thicker overburden, and as we were cutting across it here in the previous schedule, we found that we were becoming waste constrained, whereas cutting sort of down through here, it enabled us to smooth the material movement profile somewhat. The second constraint, as I mentioned, was sort of around the mining and processing rates. So we set up capital expenditure items around the purchasing of an additional MUP. Scheduler indicated that the optimal sequence was to expand immediately due to the effect of discounting. Often, as Matt mentioned, it'll generally pick the best time in the schedule. Often what you find is that's as soon as possible. After discussion with the client, however, this was deferred to year 3 based on the availability of the mining equipment. And the start point of the second MUP was determined considering a practical mining sequence and targeting the highest value ore available at that point in time. What we found, which was interesting, was that the ore mining target was unable to be achieved in some of these earlier periods here. However, as the revenue was linked to the concentrate tonnes, we found that it started targeting the higher value material in order to max out our concentrate tonnes while still not reaching that constraint. So that was an interesting change in tack that we found from the base case schedule. Around the mining rate, the overburden mining is directly linked to the processing rate based on the mining sequence that I explained earlier. So we set up capital expenditure to model the purchasing of additional excavators and trucks, and these were then considered in the schedule with the constraints lifting if and when scheduler wanted to purchase an additional fleet. The net result was a smoothing of the material movement profile as now the material movement was governed by truck numbers. So you can see here, it was sort of an incremental increase rather than previously it was sort of jumping around all over the place. The third constraint was around noise and land access. So noise modelling was undertaken to assess the impact of mining with respect to a number of identified receptors adjacent to the mining lease, which you can sort of see on this image here. Sorry for the guy, I just realised I'm pointing on this one and not on that one. But so these are all landowners adjacent to the mining lease here. So we identified 10 zones based on the allowable noise limits that came out of the modelling. And then we estimated from that the maximum equipment numbers per shift that were available and the number of shifts that we could mine in a 24-hour period. And from that we were able to calculate a daily production rate for each zone. We then set a process up in Minemax Scheduler to reflect the number of hours for an excavator to mine a block, which was again good because that's a time-relevant constraint, so essentially the available hours per period, which was useful for us as we had a schedule that went from quarters into annualised later in the schedule. And then that was then able to be applied to model the productivity reduction when mining through each zone. This normalised the mining areas and allowed scheduler to optimise the excavator efficiency across the life of the project, which we found was a more effective approach than a typical sort of rate constrained or tonne constrained schedule. I guess in a tonnage constraint schedule you would have to set up each region and set up constraints like that, whereas having just one process that we could constrain did it all for us and improved our import time as well. So just continuing on that, 5 different scenarios were then run, modelling the removal of these limitations through the purchasing of the adjacent land. These scenarios range from a do-nothing approach to acquiring all of the receptors. The previous study work that had been completed by the client hadn't necessarily indicated which receptors they were going to go forth and purchase, so this really allowed us to discretise the zones that had the biggest effect on the project value. So the capital expenditure of acquiring these receptors was incorporated into Minemax Scheduler and linked to an improvement in productivity. And this process, as I mentioned, informed which receptors should be acquired and those that added no material benefit to the overall project value. It also identified which areas should be accelerated and decelerated based on the preferred mining areas. And I guess similar applications in coal may be when modelling, say, biodiversity offsets in order to define a mining sequence. And as I mentioned, generally scheduler will want to expand as early as possible due to the effect of discounting. So the good thing about the capital, linking the capital to the mining areas is you can sort of model that as you go through the schedule rather than an upfront cost incurred. Despite the addition of all the previous constraints, the schedule still had some issues around practicality. What we found was often that the topsoil and overburden was stripped too far in advance of the ore mining. Additionally, there were some real operational constraints around the volumes of open void that we had for dewatering, and we needed to address those. So these issues often also meant that there were some large fluctuations in the truck hours when we went through the reporting. So it's interesting, actually, Matt was talking about flipping the model to a vertical orientation. I've sort of tried to do something similar with this schedule. So the topsoil, overburden and ore components within each strip were set up as dummy pit stages, essentially, so we could link them that way. And then the blocks were set up as dummy benches. So we basically had the bench number decreasing as we go down through the strip, down through here. And then we controlled them using VRA constraints, which allowed us to sort of control how far we could progress through a strip in each period. We also then set up a number of detailed precedences in Excel, which you'll find when you use Minemax regularly becomes your second best friend. And they had maximum and minimum lags set up to them that we could then just copy and paste them back in if we wanted to adjust them at all, because I think there was around 500 or so. And this enabled us to produce a schedule which minimised the haul distances as well as factoring in the time to dewater each mining block, as well as considering the deposition of tailors within each strip. The backfill of the voids within the backfill of voids with the overburden was also modelled in Scheduler, as I mentioned previously. So the backfill blocks were imported in the backfill model was imported into Minemax Scheduler and linked to mining blocks through precedences in order to minimise the haul distances. And the volumes of these blocks were adjusted considering the placement of sand tails that were coming out and being produced, and they were adjusted accordingly. There's been a lot of discussion around import and running time. So what we found, we ran a lot of scenarios. So in order to decrease the import time and the running time, we didn't actually import a visualization for the backfill model. Instead, we post-processed an animation in Datamine with the schedule results coded into the wireframe solids, which I will go through now. This works, yep. So this was the resultant schedule. You can see the first MUP begins adjacent to that valley. Backfilling is following on behind the mining process, and it's following that, maximising the total value per ore tonne. In about year 3, you see actually here, it's taken out that mining block adjacent to the road and tried to backfill it as quickly as possible so we could reinstate that road. What we found, which you'll see later on in the animation, is there was a road sort of through the southeastern block that had to be in place at all times. So we kind of had to jump the sequence down, take out a block beneath it and backfill as quickly as possible, relocate that road, and then take out the blocks where the road originally was, and then move it back once the backfilling had been completed. And so the client obviously was quite happy with the schedule in the end, and we did see a material increase in the project value when we compared it back with the PFS. But I think the main benefit was looking at all of these practical constraints which were real in this project, and considering how we could get a mining sequence that ticked all of those boxes, and using Minemax we were able to do that. So it was a good result in the end. This is just play through here. It's pretty straightforward from this point. You can sort of see the backfilling of the previous, well, this is where the previous road alignment was. As it comes through and backfills here, the road was then relocated back. And as I mentioned, all these costs were modelled in Minemax Scheduler, but they were negligible when you compare the actual project value. So, thank you for listening, and yeah, if anyone has any questions, please ask. Yeah, so we didn't do it in Minemax. We used an external package because we wanted to consider things like fuel burn, and I guess, you know, I'm not 100% sure on where the Minemax haulage sits with regards to rim pull and retard and that sort of thing. So that's kind of the process we've had in the past, and so that was sort of coded into the CSV model imported. So.
How do you normally process the data?
So what we've found in the past is that we try to keep our models as clean as possible into Minemax Scheduler. So really, let's say we're considering haulage, we might have, your travel time, fuel burn. As far as the geological side of things goes, it's pretty much just tons and grade really and densities. Because all of the stuff that comes out of that we can set up in processes in Minemax Scheduler and also calculate that in Minemax Scheduler, because one of the most frustrating things I guess we've found in the past is you code it all into a block model, import it into Minemax Scheduler, and then any changes you might make from that point requires another import. And if you have it all set up in the front end of Minemax Scheduler, you can really adjust stuff on the fly, which is, I guess, one of the strengths of Minemax Scheduler we've found. Yep.
So the scenarios where you purchase the receptors.
Yep. Yep.
Was that like individual manually driven cases, or that's you give all the information and Minemax actually dynamically makes it so receptors divide?
Yeah, well, yeah, you can. So essentially, you can link the receptors to each of the zones, and then you can run a schedule and also say which ones it wanted to purchase, which ones it didn't want to purchase. For the purposes of this project, we sort of really wanted to work out what the heavy hitters were, and so we set up a number of different scenarios and just ran them and compared the value along the way for this one, but you certainly could set them up all in one. Yeah. Any more questions? Everyone's probably thinking about a beer at this point. No, we actually haven't, but I imagine it would be pretty similar to setup, to be honest, and I'm sure yourself and Matt, you probably modelled this yourself, but yeah, we haven't done that as yet. But, it's something that you certainly could look at, say there were tax implications to progressive rehab or something like that, all of that. Really, I think what we've found with Minemax, if I look at back when we first started using it to now, is any scenario you can think of, there's a way that you can model it in Minemax Scheduler. You just sort of need to stare at a wall for a while and work it out, I guess. So.
Yeah. We can potentially help you with the fact that you went through the process of potentially flipping the model on its head and restructuring things.
Yeah.
A lot of times with clients will send in tickets and be like, well, we want to do this, but we can't figure out a way to do it in schedule. It might come down to something like that, where you need to restructure how you're thinking about what physicals and change orientations or change. Just because we call this a block doesn't mean it has to be a block in schedule.
100%.
This whatever you want.
And it's I guess to that point we did another project in Africa a few years ago, which was modelling mining of tails, and the blocks were. It's interesting that you've got the polygon tool now, which is really great, because at the time trying to get the visualization of how this sort of set up, when you got fixed widths and heights and stuff, it was quite difficult, but it actually was a really instructive tool, and in the end, as far as presenting to the client, we just coded it back into the wireframes and showed it similar to this. So all's well that ends well at the end of the day, but yeah, I mean, we've found applications for Minemax that probably originally when it started were never intended, but at the end of the day, it's numbers in, constraints, numbers out. So you don't have to be limited by how other people are using it, for sure. Yep.
Well, this project was training ever considered in the motion. Why did you go training instead of changing?
I am certainly not a mineral sands guru. I sort of came in to do the mine planning side of things. So Pierre Federici, who some of you guys may have heard of, is probably a guru who can go through that. But yeah, I couldn't answer that question, unfortunately. Sorry. All right.
Great. Well,